Next up, we'll look at this one. I'm going to draw a backbone that has 7 carbons in it. So we'll have 1, 2, 3, 4, 5, 6, 7. And then we're going to put one above the second carbon atom. And then we'll count 1, 2, 3, 4, 5. And we're going to put a 2 carbon branch down below the 5th carbon. Then we're going to add in some hydrogens. This top carbon will have how many?
3.
3. Then we'll go to the bottom one. This one here would have 3. This one here would have 2. Then we'll start on the right hand side. This would have 3. How many here?
2.
2. How many here?
1.
1. How many here?
2.
2. How many here? 2. How many here? 1. And how many here?
3.
3. Now, a good way to check this, to make sure we have the correct number of hydrogens, is to count up the number of carbons. So at 1, 2, 3, 4, 5, 6, 7, 8, 9, that makes 10 carbons. So if we have 10 carbons, how many hydrogen atoms should there be?
22.
22. And how do we know it's 22? The general formula again is
Times 2 plus 2.
CnH
2n plus 2.
2n plus 2 is our general formula. So again, we should check to make sure that we have the correct number put in there. So if we count, we have 3 on the top. This makes 6, 7, 9, 11, 12. That makes 14. That's 17. Plus 2 makes 19, and 3 more makes 22. So we should always go through and check to make sure that our number of hydrogens is correct. The parent chain here has how many carbons? 7. Going across right here. Then, if we want to come up with a name, now we have multiple branches. And we will look at this right here. It says for multiple branches. We're going to count in the direction that gives us the lowest number for any branch off of the parent chain. So if we come back here, we can count 1, 2, or in reverse we count 1, 2, 3. So the direction we want then would be from left to right. So if we count from left to right, we have 1, 2, 3, 4, 5, 6, 7. Once we establish a direction, we have to keep going in that direction. How many branches do we have off the parent chain?
2.
We have 2 branches. We have 1 here and 1 down below. So now if we want to assign a name to this, we'll start with the parent chain. Parent chain again has how many carbon atoms?
7.
And a 7 carbon alkane is called heptane. If you don't know your prefixes yet, you better get back to reviewing those. It's heptane. Now this is a 1 carbon branch. This is called a what? What is this one called? Methyl group. And this one here is called an ethyl group. So I have a methyl group and an ethyl group. So now when these branches are different, so if we have branches of different types, then what we do is we take the alkyl groups and we name them in alphabetical order, with the number indicating the position of each alkyl group off the parent chain. So in this case here it shows 3-ethyl, 2-methyl hexane. So we come back here. The branch that's going to come first alphabetically would be methyl. And the second branch then would be, whoops, which one's going to come first?
Ethyl.
Ethyl. And why ethyl before methyl?
E comes before M.
E comes before M, right. And so methyl will come second. And then we need to put a number in front of the methyl group. What number goes in front of the methyl group? 2. And the number that goes in front of the ethyl group would be 5. Now we need one more thing in here, and that would be hyphens. And so whenever we have a number and a letter, hyphens separate numbers and letters. And this then is one word. It's 5-ethyl 2-methyl heptane. And so now you think back to maybe looking at those shampoo bottles or whatever. You look at those long names of the chemicals that might be on there. And you wonder why they are so long. It's because we have a systematic method of naming them that helps tell us where those different parts of the molecules are located. Another thing you should do is just check your math. If you add up F, meth, and hept, this would be 2 plus 1 plus 7. And so that should add up to be the 10 carbon atoms that we see up above. And so there's many checks you can do to make sure that what you're doing is correct. And I'm just going to keep going on these. If you have questions, just stop at any point. We're looking at several examples today. So any questions yet? Okay, today is all about examples. Let's look at another one. This one here, we're going to draw 6 carbon atoms in a row. 1, 2, 3, 4, 5, 6. And then we're going to branch one off down at the bottom here with 2 carbons. We're going to stick one here up off the 3rd carbon and another one off of the 5th carbon. So this is what that backbone, carbon backbone, looks like. So we have a total of 10 carbons. If we have 10 carbons, that means we should have a total of how many hydrogens?
22.
22. So let's see if we wind up with 22. How many hydrogens on this one?
3.
3. On this one here we'd have? 3. Go to the bottom. This would have?
3.
3. This one here would have?
2.
2. And then we'll go from right to left. This one here would have? 3. This one here? 1. This one here? 2. This one here?
1.
This one here? 1. And on the left-hand side?
3.
3. And then if we check our math real quick, we have 3, 6. This makes 9. There's 11. This is going to give us 14, 15, 16, 18, 19, plus 3 more is 22. So again, we check our math each time, and then that way we can be confident that we have the number of hydrogens correct. Now, the next question is then, we want to name this, so we go back to our rules, and we want to identify and name the parent chain, which again is the longest consecutive chain of carbon atoms in the molecule. What is the longest consecutive chain of carbon atoms in this molecule?
6.
I hear 6 and I hear 7.
7.
And where do we get the 7 from? Yeah, we start down here. So if we count, and this is, you have to trace through all the possible combinations you can get to get the longest path possible without lifting your finger. If you do that, we get 1, 2, 3, 4, 5, 6, 7, all the way through there. So remember, part of the reason for that is that single bonds always have the capability of rotating and twisting. And so this one here is one where it's just twisted around and it's pulled down below. And again, it comes from the fact that single bonds are always in constant motion. They have that twisting and turning that can occur. So we trace through that parent chain. Again, that parent chain has 7 carbon atoms. So a 7 carbon backbone is going to be called heptane. Then we start counting the branches off of the parent chain. We have 1 branch here, 1 branch here, and 1 branch here. How many carbon atoms are in each of the branches?
1.
1. And a 1 carbon branch is called a methyl group. If we have 3 of them, that would mean it's trimethyl. So this is going to be trimethyl heptane. Then we need to assign the positions. So we're going to count from the direction that gives us the
Fewest.
lowest number. So if we counted this direction, we come up with 1, 2, 3. Or if we count in the reverse direction, we come up with 1, 2. So it looks like we're going to start counting right here. So we're going to start counting from the right hand side, and we'll count 1, 2, 3, 4, 5, 6, 7 for the number of carbon atoms. Then we want to tell where each of these carbon atoms are branched off. So this one is branched off of number 2. This is off of number 4. And then this one here is off of number 5. So how do we write that then? Be 2, comma 4, comma 5, trimethylheptane. And we read this as 2,4,5 trimethylheptane. So any questions on this particular structure? 2,4,5 trimethylheptane. Okay, then you try drawing these two. So we'll try this one. 4-ethyl. 2,3 dimethylhexane. And then we'll try this one here. That's going to be 3-ethyl, 4-propyl octane. So draw structures for each of these two. So check your answers out here. Any questions that you have on them? Without counting the carbons here, how can we get the number of carbons from the names? Eth means 2, prop means 3, and oct means 8. So 2 plus 3 plus 8 gives us 13. So it'll be C13, which means there should be a total of 28 hydrogens. This is 2n plus 2. And if we count, we have 3, 5. This makes 8, 10, 11, 12. That's 14, 16, 18. 3 more makes 21. Plus 2 is 23, 25, 28. There's a total of 28 hydrogens in there. Andrew?
Where's the propyl at on the sheet?
Okay, that's not on there. And the reason why that's not on there is because the way that we get alkyl groups is that the alkyl groups are named from the alkane. Well, I guess it is kind of on there. It comes right up here. An alkyl group is an alkane that has had 1 hydrogen removed. And so what we do then is that's a 3-carbon group. And so a 3-carbon group has a prefix of prop. And so we'd actually call that propane. If we take a hydrogen away from it, we change the A and E suffix to YL, and so propane changes to propyl. And so propyl is going to be a 3-carbon group that would be attached. Butyl would be how many carbons? 4 carbons. If it was octyl, it would be 8 carbons. So it's basically whatever that alkane is with 1 hydrogen removed. Okay, anybody else?